Hello everyone, welcome back to another exciting chemistry video lessons from Adrenaline the Bazooka Prophet, CEO Adrenaline online tutorial platform, the Masters platform. Now in this video, we're going to be talking about a very important aspect of organic chemistry, which we talk about the stereoisomerism. And under this stereoisomerism, our major aim and target is to talk about what we call the arrow and X configuration. But before we talk about the arrow and X configuration, we should understand that this falls under what we call enantiomers. Enantiomers. And we said that enantiomers are non-superimposable. Look at this word there. It must be there. Non-superimposable mirror images of each other. And it is from these enantiomers we tend to get what we call the D and L. Because for you to be an enantiomers, you must possess chiral carbons. Chiral carbons. And in my previous videos, I talked about that chiral carbons are carbons with 4 different groups attached to it. The group must be different for there to exist in it chirality. And I said that under the enantiomers, what we call the D and the L, that when a rotation is to the right, it is dextro-rotatory. If it is to the left, it is levio-rotatory. And we use the symbol L to denote what now? Levio-rotatory. What then are diastereomers? Because we cannot talk about enantiomers without talking about what we call what now? Diastereomers. Diastereomers are 2 things now. They are not superimposable, and they are not mirror images of each other. Take for example, your left hand and your right foot, right? Look at it here. They are not superimposable and they are not mirror images, even though they are both left-handed. Look at it. This is how you know superimposable. Something like this now is superimposed, while like this it is not superimposed. I mean, they cannot merge, but like this they blend. See, I'm trying to give you a basic explanation so as to calm your curiosity, not living on assumption. Is that clear now? Now, there are some examples of compounds given to us here. This is a molecule. And arrow and X configuration, we said, for you to be in the arrow direction, arrow means rectus, meaning when a rotation is to the right, it is clockwise, just the way your clock moves in a clockwise direction, meaning to the right, something like this. While for X means sinister, which means the rotation is anti-clockwise, which is moving in the left direction against clock, meaning the arrow is clockwise, rectus, the word rectus, sinister, what now? It moves in the anti-clockwise what? Direction. Now, in trying to understand configuration of arrow and X molecules, we must understand some basic tips here. Now, we have arrow and X for what we call the perspective form, right? Let me erase the board. Now, there are 2 ways of identifying the arrow and X configuration of molecules. We have what we call the perspective form and what we call the Fisher's form. Perspective form and Fisher's form. So in this video, our interest is to talk about the perspective form. And under perspective form, there are some basic things we should understand. One is that when you see this wedge means the molecule is facing you. That's the meaning of the word wedge. The thicker bond here is the wedge. Why this one here that you are seeing, they are called the line bond. Why this one here is called the dash. Is that clear now? Now, please do not be confused in this case. Always know that the least atom is always placed in the dash. Take note. The least atom in an arrow and S configuration is always placed in the dash when you are making use of the perspective format. Now, let us do it together. Now you understand this wedge. Let me spell for you. There is called the wedge. Why this line here you are seeing here is called the dash. Why this one here is called what now? The line what now? Bond. So if that is well noted in your notebook, now let us move ahead to now assign arrow and S configuration to these two molecules where it has just one chiral center. Just one chiral center. Also move to multiple chiral centers in our next video. So do well to subscribe, like, and share because there is so much in stock for you today. Yeah, let's go. So how do we do that? Let me erase the board to create more space for what we're about to do. Now look at it now. How do I assign it? Very, very simple. I come here to say, now look at it. It just like the E and Z notation I did in my previous video, the same similar idea that it is done based on the atomic number. Meaning this bond here now is directly attached to bromine. This bond here is directly attached to carbon, not this old substituent, but rather we talk about directly attached to the atoms, right? So this bond is attached to oxygen. Yes, attached to what now? Hydrogen. So in terms of now I'm having bromine here, I'm having carbon here, I'm having oxygen here, I'm having hydrogen here, right? Now, which of them here has the higher atomic number? Of course, it's bromine. So bromine we take 1. Carbon has atomic number of 6. Oxygen has atomic number of 8. Hydrogen is what now? 1. So oxygen here, we take the next priority here, which is 2. Followed by what now? Carbon, which is 3. See the way it's going. Just look at the way your eyes are going. It's not going like this, right? Why the least is what now? 4. The least is always ignored. The least is always ignored. When you are not contributing to the affairs or the building of nations, you are always ignored because you don't have anything to say. That is why you could see it now. It was being ignored here, moving in this direction. You see it now? So the direction here now is in the arrow what form. So this is arrow form. So that immediately you now know that it is arrow form, then you can now name it. Right? How you pack nomenclature here? Of course, you only have 2 carbon here, right? So if you're having 2 carbon here becomes what now? Here becomes, so now that you have been able to identify that it is arrow direction, then I can now erase this now so that I can now name it. I can now name it in IUPAC nomenclature now. Now I'll be able to identify that it is arrow direction, so I can now name it. Now I'm having just 2 carbon here, so that if I'm to start my numbering, here will be 1, here will be 2. So that here becomes what now? 1 bromo, right? Ethanol. So here becomes arrow 1 bromo ethanol. That is the correct answer to this one. Now you notice arrow direction, and take note, I've told you before, for here to be a chiral carbon, it must have 4 different groups. Now let's go. Now the next one here is this. Of course, if I'm to number this one here, right, here will be 1, here will be 2, here will be 3, here will be 4. See the way it's going now? It's going in this direction also, right? But there is a problem here. There's a problem here. In my earlier statement, I said the least atom is always placed where? In the dash. Right? Hydrogen here, the least atom here. This is its place. It can be, it is not only applied to hydrogen. Any atom that has the least atomic number is always placed in this dash. And if that is noted, if you have that knowledge, what would you now do? You have to now what now? You have to swap it. So that if it was going before in the arrow direction, but because hydrogen is placed wrongly, right? Or hydrogen is not here, because you are swapping, right? Here becomes what now? The X direction. Exactly. So the correct number, so the correct name now, or the correct configuration is in the what now? X direction. So that you can now name it again the same compound here. That becomes 1 bromo, right? Ethanol. Now, to know more about all this, of course, we offer online international tutorials for students to go deeper into all these aspects, to know how to swap it, to know how to interlock it. I remember humble self, and adrenaline the bazooka prophet. Thank you, and God bless you.